Yeah, so thank you. Hey everyone, I'm Danica Fine. I lead open source developer relations at Snowflake. Mostly as an IC, I'm focused on Apache Iceberg and Apache Polaris, which is directly relevant to today. So I'll be giving you hopefully what is seen as a balanced tour of the Iceberg catalog landscape, so that ideally by the end you have all the information that you need to go back and hopefully make an informed decision about which catalog you should be using. All right. So to give you an idea of what we're going to go into, and obviously, okay, I don't know if have any of you attended one of my talks before? The what? Does the panel count? I guess so, but I didn't. Okay, so when I do tech talks, I like to enjoy myself, even if it's a dry topic. So we have adorable cats joining us today. Thank you, Gemini. All right, so what we're going to be walking through today, first of all, so level setting on some foundational context. I have heard that Iceberg is a bit of a buzzword, so I want to make sure that for those of you who are only here for the buzzword, that you have all of the foundational context that you need going into it. So what Iceberg is, why the catalog is an important piece of what we're looking at today. And then we'll get into the REST catalog spec itself and why it's really been a game changer for Iceberg catalogs overall. And then from there, the bulk of the talk is going to be a rapid tour of the major catalogs, four in particular that we will be going into a decent amount of depth, and then a couple of other ones just to kind of round it out and give you a better idea of the entire landscape. And then we'll close with, again, a practical framework for, asking yourself some really pointed questions, and hopefully you'll decide what you actually need to do in the end. Okay? So first of all, before we dive in, I want to situate everyone else into sort of the data lakehouse and the different components that make it up, because that catalog plays a very specific role in the stack. So first of all, we have the storage layer, right? This is where the individual data files, the rows of your data lakehouse actually live. This could be file system, this could be object storage, S3, GCS, Azure. From there, on top of that, we have the table format, and this is what actually helps us make sense of those raw data files that we have in storage here. This adds, the structure, it adds meaning, it's the layer that's tracking the schema, the partitioning, any snapshots, and obviously the table format that we're talking about today is Iceberg, okay? But there are many other ones out there, just saying. Okay. On top of that, we have the catalog layer, the piece that we care about for the purposes of this talk. The catalog, what it's doing at a high level, and we'll get more into this later on, it's cataloging, the indexes of your Iceberg entities, right? Your namespaces, your tables, and it's doing that so that other layers of this, the query engines, can then find these tables and interact with them. It is the source of truth for which tables actually exist in your lakehouse. And where their metadata actually lives underneath in storage. And then finally, at the top, rounding it all out, we have our query engine. This is, take your pick, right? Spark, Flink are sort of the big Iceberg open source ones, Trino, DuckDB, so on and so forth, Snowflake, Databricks, what have you. The query engine is going to be talking to the catalog then to discover tables and figure out where they actually are based on the format, and then it's going to use that to access them down in storage. Okay, so these four layers are constantly working together, but again, we're going to be focusing on the catalog layer here. Now, how many of you are currently working with Iceberg? Okay, how many of you are here just for the buzzword of Iceberg and you have no idea what you're doing? Great, cool. All right, so we are for you, sir, in the back. So for those of you who just need a refresher, okay, because I'm sure everyone does, what Iceberg is and why we even care, because it's super cool. That's a pun. Okay, so it is an open table format. It's optimized for large-scale data sets in a data lake. It is a format, right? It's a specification. All right, just it's a set of rules that defines how we should organize files in that lower storage layer so that we can get reliability and performance of a data warehouse in a data lake without vendor lock-in. Oh my gosh, there's so many good things there to unpack. But the biggest thing here to remember is Iceberg is not a database. Okay, Iceberg is not something that you just run. It's not a query engine. It is a format. It defines, it's a set of rules for how we're going to lay out the data in that table format layer and what that metadata looks like so that multiple engines can interact with those tables, read and write from those tables safely, and it's become the standard for open lakehouses. All right. So again, a refresher for those of you who haven't really thought about it in a long time. So if you've dealt with Iceberg at all, no doubt you've seen some variation of this diagram before. This is what Iceberg actually is. Once you've kind of created a table and you have some files floating around, this is Iceberg. It is not a thing you run. Iceberg literally just defines what this metadata looks like so that we can then access the data files. That is it. But walking through it from right to left, so all the way over on the right, we have our data files. Again, these are the rows that we are storing in our Iceberg table. These are usually formatted as Parquet, but you do have flexibility. I have seen humans using ORC, but mostly Parquet. All right, so from there, we get to the actual metadata layer. Oh, and also in the data, that's not only the rows that you actually have in the table. If you have any deletions, this is also where we track those as well. Okay. And then in the metadata layer, the first entry point to the data files is the manifest file. So your manifest files are going to point to a specific subset of your data files, and they're going to just describe what those data files look like. Okay, so for each of the columns in the data files, the manifest file will keep track of the max and min for those columns. So we just have an overall idea of what what is being stored in that data file. And the purpose of this really is to make things efficient for query planning later on, so we can prune things off if we don't need it. From there, we roll up to the manifest list, and so you'll see here that you'll take it's a list of manifest files. Okay, the naming is very, very clear here. So the manifest files from a single snapshot of the table will roll up into a single manifest list. Okay, so all of the statistics that we have at the manifest file level are going to be rolled up into the manifest list, and we're then going to kind of aggregate them into a holistic view of what does this table look like by partition. Right? What are the max and min values of the partitioning column, and what is currently stored in these manifest files? What are each of these manifest files actually tracking? And again, the purpose of this is for efficient query planning. We want to prune off as much as we can, as early as we can, so we don't have to touch any of these files. Okay. And then after that, we have the metadata file, which keeps track of all of the recent snapshots of this table. So you'll see that there's pointers from each of the snapshots to the manifest list for that snapshot. And then the metadata file also, unsurprisingly, stores metadata. Things like, what does the schema currently look like? What is the schema? What did it used to look like if we evolved it? What is the current partitioning spec? What did it look like before, right? And cool, so that's kind of a lot. There's a lot of files floating around. And this is just for one table, and this is just for 2 updates to that table. So this is going to get pretty wild pretty quickly, all right? So we need one more thing. We need a catalog, all right? Because otherwise, this is a ton of files floating around in object storage. How are we making sense of them? How do we understand where our entry point into this is for a given table, all right? And so, realistically for the table, what we care about is that most recent metadata file. Right? That is our entry point. That has the most up-to-date snapshot, and it's our entry point into all of the files that we're going to need to do our effective query planning. So the catalog, what it is doing is it has a mapping of our table or entities, and it maintains that critical pointer from the table identifier to that most recent metadata file, and it is going to update this as we create more snapshots for that table. And ideally, it does that atomically so we don't clobber everyone else when we have multiple writers interacting with our Iceberg table. All right. You might still be very frustratingly or annoyingly asking yourself, why do we need a catalog? I can just do it myself. And you could, but if you do it, you're just going to be creating a bespoke catalog. So, okay, good luck. But seriously, if we take a step back, why do we need the catalog? There's 2 main things, okay? The biggest one is discoverability, as we saw. You need to be able to find your tables. There's a lot of files floating around. There's a lot of metadata files floating around that could potentially be entry points. So we need to know for a given table ID, what is the first file that we need to look at to actually query this table effectively. Also, within a namespace, what tables are even there? If we need to create a new table, this is what a catalog should be able to do, and drop old tables. Right? And then the most important piece, I think, is to help us maintain consistency. All right? When multiple engines are reading and writing, interacting with a table, someone needs to coordinate how we update that metadata pointer when we're adding new rows to the table or changing it. Right? And the catalog is going to do that with atomic compare and swap operations. Okay? So yeah, you need a catalog. It's important. But the super fun thing is that the Iceberg project does not ship with an official implementation of a catalog. It's left as an exercise to the reader. It does provide a Java interface with the requirements of what a catalog should do, so we know what it should do. And there are a few client implementations out there for Hive, for JDBC, for REST. The actual catalog servers itself, those come from the ecosystem, which is why we have so many options, and it's probably why you're here to learn more, because it's chaos. Okay. So let's now, before we get into an exploration of some of the catalogs, let's talk about one of the most significant developments in the catalog space in recent years. And this is really the REST catalog specification. Okay. And first of all, when we talk about the specification, remember I said Iceberg itself is a specification, but really it's a collection of specifications. There's the table format specification, which is what I showed you when I laid out all of those files for you. That defines what that should look like. There's also the REST catalog spec, which defines how catalogs should look and feel. There's also the Puffin spec, which defines what Puffin files look like, which is actually a thing in Iceberg. It's very cute. But there's a collection of specs that really make up Iceberg. Okay, but we're going to focus on the REST catalog one. So before the REST catalog spec, every catalog had its own bespoke protocol. All right, Hive used Thrift. Nessie had its custom GitLike API. JDBC used direct database calls. But what that meant is that every engine in every language needed a custom client class for every catalog that it wanted to support, which is horribly inefficient and does not scale. Right, that's an N by M problem to solve. Every time you want to add a new catalog, you need to re-implement it in Java and Python and Rust and Go. If you wanted to add a new engine, you needed to implement support across every catalog. Right, and there's no way in all of that chaos also to ensure that everybody is running the latest version, but that's a different problem. All right, so the REST catalog spec solves this. Instead of having custom wire protocols here, you instead have a single standardized HTTP JSON interface. Great. Every engine just needs one REST client. That's great, and that exists in whatever language we need it to, and then it can talk to any other catalog that implements that spec. Nice. And then one of the nice benefits of that is that the catalog server is going to be able to handle everything for us behind the scenes. Metadata storage, conflict resolution, access control. The clients are staying lean and simple, and we can push everything back to the catalog server as much of it as possible. Okay, so really this is a big deal, right? We're taking it, we're kind of pushing that back to the client server, and once we're centralizing it, we unlock a lot of cool capabilities. Well, first of all, as you already saw, we have maximum interoperability, and that's really what people are after when they're using Iceberg, right? To avoid that sort of vendor lock-in. And it was kind of a shame before the REST catalog spec that we also had sort of this very limiting piece of, oh, well, are we really interoperable? We have to keep recreating this. So the REST catalog spec was sort of a natural progression there to help us achieve this interoperable nirvana, right? But for some of the benefits that we actually get from here, so server-side conflict resolution, this means that your clients don't actually have to handle commit retries. The catalog instead can take care of it for them. The centralized, having it all together and centralized on the metadata side, this unlocks something, things like multi-table transactions, where you can kind of atomically update all of those at once. We also get lazy snapshot loading, caching, temporary storage credential vending, where engines never actually need direct access to your buckets. We're just going to let the catalog manage doling those out. So yeah, there's a lot of cool things that we get with the REST catalog spec just by actually laying it out and defining what this looks like. So the spec isn't just a client protocol, I'd say. It's really, as I said, becoming more of an interoperability contract for the entire ecosystem, right? And that's kind of what, as you'll see, is making this idea of the modern Iceberg catalog possible. All right, so very quickly, what does the spec actually look like? What does it define? It's straightforward REST. You can list namespaces, list out your tables within them, create tables, load a table to get its current metadata location, and then commit those updates atomically, right? Authentication is handled by OAuth tokens. Great, pretty basic. And the beauty is in its simplicity, right? Any HTTP client in any language can then speak this protocol, and then everything flows through that central server so that the server could then, if it chooses to, layer on additional capabilities like we discussed, right? That access control, the conflict resolution, credential vending, and what have you. And we'll see a lot of these come up as we go into the specifics of a lot of the catalogs. Okay, now, things are going to get a lot more adorable, okay? Let's herd the cats. I really enjoy the puns of this talk. So as I mentioned, we're going to go deep into a couple of catalogs, but round it out for completion. So first one, Hive Metastore. So this is sort of the OG, the incumbent. If you've been in the Hadoop ecosystem at all, you know HMS. It's been around forever, and for many organizations, it's already there. Okay, so it's something that is definitely top of mind when they're considering moving over to Iceberg. So Iceberg, thankfully, it does ship a Hive catalog client that can store your metadata pointers in Hive Metastore already. So you can use your existing infrastructure. If this is the situation that you're in, great. You can stop here if you wanted to without adding any additional services. One thing that's worth calling out is how it handles concurrency. So HMS uses a database level lock for its metadata pointer updates. That's coarse-grained, and you can kind of compare that to the REST catalog's optimistic concurrency with the compare and swap, right? But it handles the multi-engine environment just a little bit better. Okay, adorable cat. All right, strengths. It is everywhere, right? It is the incumbent. If you're migrating to Iceberg from a Hive-based data lake, you don't really, at the get-go, have to change your entire infrastructure just to choose a catalog. Every engine in the ecosystem is pretty much going to have that Hive client implemented for you already, so you're welcome to kind of use that. But the limitations are going to be real. Thrift is aging. No rest means you're stuck in the N by M sort of problem space that we already discussed. The locking model, honestly, is just not designed for the kind of concurrent multi-engine access that you might be striving towards by moving to an Iceberg-based data lakehouse. And you're not going to get any of the good things that sort of the REST protocol gives you, like credential vending or server-side conflict resolution. So the verdict is basically, if you're already in sort of a Hadoop-based environment where you have Hive Metastore and you're starting your Iceberg journey, great, it will work for you. But I don't think that you should be looking at it as a long-term plan. You should use it as sort of a step for a migration process. And if you're greenfield, do not choose this. Great. All right, another adorable one, Glue. So if you're all in on AWS, how many of you are? Okay, thank you for being honest. If you're all in on AWS, this is your path of least resistance. You may leave after this slide. So it's fully managed. You don't have any servers. You don't have any database maintenance that you have to do. What's nice is that Iceberg is considered a first-class table type in Glue. And then you're going to get that native integration with Athena, with EMR, with Redshift Spectrum. Great. It does the thing, I think. Well, it kind of does the thing. Okay, so the interface is obviously going to be AWS proprietary API, though they have added a REST adapter for engines that do speak the Iceberg REST spec. Lake Formation also sits on top of this, so it's going to give you some of the nice things like fine-grained access control and also credential vending, right? So one technical note worth mentioning, Glue handles Iceberg commits using conditional writes. So it's kind of a check and set on the Glue table version number. If during that time another writer has since updated the table, after you've read it, then your commit's going to fail, right? And it's going to retry it. It's kind of similar to the optimistic concurrency that is already happening with a lot of the REST-based clients. It's just implemented through AWS's own API instead of the standard spec. So I'd say the consistency guarantees are pretty solid. The limitation is really just more about portability than correctness. All right. The actual pros and cons, I mean, honestly, the trade-off here is pretty straightforward. You're getting operational simplicity in exchange for ecosystem commitment. Cool. So if your data, if your commute and your team are all on AWS, it's pretty hard to beat, I'll be honest. But if you have multi-cloud ambitions, maybe you do, or if you want true engine portability, you're building on a proprietary foundation, right? So the REST adapter can help you, but it's kind of just a compatibility layer. It's definitely not a native path, okay? I wouldn't rely on it too much. And then at scale, obviously, those APIs, that API is all that cost is going to add up. And then your catalog metadata is going to be living on AWS, which means migrating away from Glue later is going to be its own project. Okay. Everything's a project. All right, so another adorable cat, alogue. We have Apache Polaris. So full disclosure, I work for Snowflake, which is the origin behind this project, and I'm a committer on the project. So I will try to give you, as an unbiased take as possible. But look at the cat; it's adorable. All right, so Polaris, it is a REST native catalog server. So the reference it can be viewed truly as the reference implementation of the Iceberg REST catalog spec. Okay, to a T. You deploy it as a standalone service. It stores its metadata in a pluggable relational backend, and then any engine that speaks Iceberg REST can connect to it immediately. So beyond the basics, there's some other fun things that we get in there: credential vending, access control for RBAC, OPA, and now Apache Ranger. You define this once, and it's enforced regardless of which engine is actually talking to the catalog. We get multi-table transactions, woohoo, catalog federation, and also conflict resolution. So the catalog federation, actually, I just want to call that out. It's kind of a big deal because Polaris can then serve as the single REST endpoint federating your existing catalogs, right? Hive Metastore, if you want to kind of use that as a stepping stone out, or Hadoop or BigQuery or what have you. And then also we have generic tables. So I know I've been marketing all of these as Iceberg catalogs. And Iceberg was sort of the impetus behind the creation of Polaris. But now we have generic tables, which means that you can interact with hoodie tables and also Delta tables as well. All right, engine support is broad. I'll stop waxing poetic. I really like Polaris, obviously. So how does it stack up? The governance story, I think, is strong. It is an open source project, multi-vendor. It's not just Snowflake, I promise. You can look at the PMC list. And it's under the Apache Software Foundation, so it means that no company truly controls this roadmap. It recently, February this year, graduated to a top-level project, so that means it kind of met a lot of the requirements and convinced enough people that it is an independent open-source project with a good track record of releases. So on technical side of things, so federation, like I called out, the catalog federation is kind of a big deal. Practically, it means that you don't have to rip and replace your existing catalog just to accommodate Iceberg tables. All right, on day one. And then I think really the expansion beyond Iceberg only is a really big deal because it's not just a niche Iceberg catalog. It is adherent to that spec, but it is not just an Iceberg catalog. Some trade-offs, mostly self-hosted at this point. There are some managed offerings springing up, but the open source project is mostly your responsibility, so you're going to deploy it, monitor it, and upgrade it long-term. The community is younger than a lot of the other catalog options we'll go through today. So you can decide for yourself if that's a good thing or a bad thing. There's less baggage, so there's that. But it's less mature. Operational tooling still catching up, still maturing to something like Glue comparatively, where AWS is going to handle everything for you. All right. Another adorable one. I think this one was my favorite cat, actually. So Unity Catalog. It is a Databricks catalog open source catalog. It lives under the Linux Foundation AI and Data umbrella. It also implements the Iceberg REST catalog spec, but only right now for read access. Okay. The backend, if you're curious, is a relational store. You either self-host or get it managed inside Databricks. The key thing to understand here when you're considering Unity is it is Delta Lake first. All right. You are writing Delta tables, and then you use Uniform behind the scenes to generate Iceberg compatible metadata so that other engines can read those as Iceberg tables. Okay. The native Iceberg write, I believe, I don't know when the next release is coming, but it's on the roadmap for the next release. It's just not been shipped yet. So where I think Unity definitely differentiates itself is its scope. It's not just a table catalog. It also can manage your machine learning models through ML flow. You can manage volumes through unstructured data, and then functions that LLM agents can then discover and call as tools. So you can register a Python function in Unity, and then agents, using LangChain can invoke it directly. So no other catalog in the landscape offers that. So it's something to consider if that's a need of yours. All right, strengths. If you want one catalog for tables, for models, for AI functions, if you're already kind of leaning into the Databricks ecosystem, Unity is really, really compelling. I think that the AI ML angle is pretty unique. No other catalog right now offers that. A function as tool semantics or a model registry, so it's worth considering. Limitations, as I called out, the Iceberg support right now is the Iceberg write is not yet shipped. The read interoperability is there. The open source version, it is still maturing. There's a couple things on the roadmap that I think are really important as governance items that are still haven't been shipped, like lineage or fine-grained security. So I would encourage you to kind of check the GitHub and see what's kind of on the roadmap for you and whether that matters. Contribution diversity, I know it is an open source project. I'm going to call it out. A lot of it is kind of Databricks dominated, though the Linux Foundation umbrella, like being under that now, should help that moving forward. But again, wanted to call that out. And then another thing, if you are a Flink shop, there's no real engine support there for using Flink as an Iceberg engine. All right, so rapid fire, a couple more things for completion, just kind of round this out. JDBC catalog, you could use that. Maybe don't, but it's pretty simple, right? It's going to store your metadata pointers in any relational database. It excels at development and testing, but please do not use this in production. It is not a good idea. It doesn't have any built-in access control. It's really not recommended. Nessie, many of you may have heard of this. This was the open source catalog that was driven by Dremio. It's a pretty niche one. It gives you Git-like branching and tagging for your data lake, where you can create a branch, you can experiment on that with data transformations, and you can merge it back if it works. It's really good for CI pipelines and data engineering workflows where you want that isolation without copying data. Again, very niche, and I would say that a lot of the stuff that Nessie had, a lot of the folks from Dremio are now working on implementing those features in Apache Polaris. So they're kind of bringing a lot of that functionality over. Apache Gravitino, another one I want to call out. This is an interesting one. It is a meta catalog. It's not meant to really replace your existing catalog, but it wants to federate to them, right? It wants to be the catalog of catalogs. So you can proxy to Polaris, to Hive, to Glue, or anything else through the Gravitino REST endpoint. It is also a top-level Apache project that graduated last year. Governance, again, just calling this out, the governance on this project is mostly from a single vendor, from Data Strato. It's worth watching, but you should probably factor that in if you're really leaning into the open source angle. And then for completion, I have to call out that if you are in the Snowflake ecosystem, Snowflake has a Horizon catalog, which has full support for all the features from Apache Polaris. Okay, so if you're looking to get Polaris functionality, but you want to be staying in the Snowflake ecosystem, you can get that through Horizon. All right. So here's an adorable table, a useful table, I mean. So for the 4 main ones that we went through, I wanted to give you just sort of highlight the main pieces that you might be comparing. This is the one to take a photo of if you care. So a few rows just to call out. I think the REST native idea, this is the dividing line, right? Hive and Glue, it's not REST native. There is obviously that adapter in Glue, but I wouldn't really rely on it as you would have the same expectations for it. Polaris was built on the spec, and then Unity implements it partially for read access right now, but obviously there's more developments coming along. That single row, I think, explains a lot of what you see beneath it. Multi-table transactions, if you need that, if you need federation, those are currently unique to Polaris, and that's a direct consequence of it being truly REST native, and those features require that server-side coordination that I called out. Multi-format is interesting because both Polaris and Unity are expanding beyond the single format. Polaris started with Iceberg and is moving outward from there. Unity started with Delta and is moving toward Iceberg support as well. But yeah, I think I don't know if I could say converging, but they're kind of expanding out in the same directions. What you'll see here, I think the main takeaway is no single catalog actually wins everything, and that's why the next section matters for you who are actually looking to make a decision. But don't worry, there are more cats. All right, so how do you actually practically narrow this down? And so I have some easy, hopefully, questions to help you decide. So the first one, and I mean this with love, is how lazy are you feeling? Okay, and this is going to help you decide if you want to manage it yourself or if you want someone else to host it for you. Do you want to commit to running this catalog long term? Do you want to manage the deployment, the upgrades, the monitoring, or would you like to make it someone else's problem? If managed, if you really don't want to deal with your catalog, if you're in the AWS ecosystem, great, it'll be Glue. If you are with Snowflake, it should be Snowflake's managed offering. If you're in Databricks, it'll be Unity. If you're willing to self-host, then Polaris, Hive, Nessie, and JDBC are all on the table, but JDBC is not really an option, so don't use it. Okay. What is your current stack? Okay, what does this look like? And I think for most organizations, practically, this is going to be the deciding factor. Okay, what are you currently leaning into ecosystem-wise? Obviously, if you're deeply invested in AWS, you're going to go with Glue. If you're running multiple engines across multiple clouds and you want something vendor neutral, then you really should be leaning in on a REST native option like Polaris. That's going to give you a lot of flexibility long term. Again, if you're Databricks, you're going to go with Unity, and you want that, you'll get that AI/ML governance story. And if you're in a legacy Hadoop environment, it's completely fine to just use Hive Metastore. All right, don't rip it out on day one. And third, you got to ask yourself, what functionality do you actually want out of your catalog? Okay, not all of these catalogs are created equal, and some of them don't even cover some of the basics that we would expect from a catalog. Multi-table transactions, where you atomically can update effects on multiple tables. This requires the server-side coordination. You need to have a REST-based catalog to get that. Access control, some of the catalogs like Polaris and Glue have this built in. Some of them leave it to you, exercise to the reader. Credential vending, a lot of the managed versions have this, and I think it's really important for folks security-wise. Legacy catalogs aren't going to give that to you. And if you have heterogeneous sources, federation is a newer capability that something like Gravitino or even Polaris is going to give you as well. And then finally, where are you starting, right? Are you starting from scratch, or do you have an existing catalog that you want to migrate away from? And this is going to obviously change a lot. If you're greenfield, you are so lucky. That is incredible. I wish you luck with your startup. Pick the catalog that best fits your ecosystem that you're leaning into from the options that we discussed before, right? Most of you aren't greenfield, right? You've got Hive floating around, you've got thousands of tables that exist already, and you're just kind of adding Iceberg as one piece of it, or maybe you're coming from a proprietary system. So in that case, I don't think you should realistically rip everything out and replace it from day one. There is a migration for you, okay? There is a path forward. So I think, for those of you who are, have HMS already, that's a valid on-ramp. You can use it while you migrate incrementally. But this is why I think federation becomes extremely valuable, right? Polaris or Gravitino are going to be able to serve as a single REST endpoint for you. You can add a more modern catalog on top of that for just your Iceberg catalogs and kind of figure that out as you migrate behind the scenes, right? That's the more pragmatic path, right? So just to summarize what these questions are, not in a funny way, but do you want self-managed or managed? What tools are you using? What functionality do you actually need from the catalog? And where are you starting from? All right, so to wrap up, I know this is a little chaotic and maybe moderately distracting because of the cute cats, but the Iceberg catalog landscape, it's rich, it's evolving fast. I think honestly, we've kind of moved away from the table format war, and now we're going into, okay, how do we have a catalog to bring it all together and help us achieve X, Y, Z, okay? So you kind of have to, keep up. It's not about table formats anymore, guys. So Polaris, I think, is expanding beyond Iceberg only, which is exciting. Unity is also, as I said, moving toward Iceberg from the Delta Lake side. And then you have things like Gravitino, who's trying to serve everything through the same interface. But I think for all of these, when you look at the newer catalogs that are coming out into the space, the unifying thread is that they're all leaning into REST. Okay, so whatever catalog you choose, if you're starting fresh, I would really encourage you all to sort of lean in on the REST catalog spec. That's how the ecosystem is going to be connecting, and that's how you're going to keep your options open, which really, that's the reason we all are using Iceberg in the first place. We want to have these options open moving forward so that we can move things around if we need to. So with that, I think I have maybe a minute or so for some questions. Thank you for coming. This QR code is not just random. It does not link to cats. It does go to my link tree. So if you're curious to kind of follow me on some of my socials, I post about Iceberg and Kafka and Polaris and things like that. So anyway, all right. Thanks. Do you have any questions?
Any questions?
Cool. I think I did a good job then. But seriously, if any of you all, you're too shy to ask a question here, I'll be here for the rest of today and tomorrow, and I'm happy to talk about any of these catalogs. Oh, we do have a question.
Yeah, thanks for the presentation. It's very informative, very interesting. You mentioned about the glue catalog that it has a high cost when it scales out. Could you elaborate a little bit more why it has this high cost, and what do you recommend to use if we scale out very quickly?
It's not really a cost from a scalability standpoint. I mean, I guess it is, but it's all of the API calls in between. And it's because you're within the AWS ecosystem, then that's going to add up. Yeah. It's less of like, oh, you can't scale, and that's directly tied to that. It's just kind of, you have to be mindful of it.
In comparison, do you have another catalog that do less API calls?
Well, if you're self-hosting something, then you're outside of, yeah.
Thank you.
That's really it, just calling it out as that fact.
Yes, since you work for Snowflake, where would you see a Snowflake in that picture? Like, is it more like a query engine provider, or do you evolve into a catalog provider? And reason why I'm asking is like for large-scale corporations, these managed services are most of the time the easier path than to self-host Spark or DuckDB or these kind of topics. So if I go to Snowflake, would you say I can get the Snowflake query engine without the Snowflake managed catalog? And the same goes for Databricks, or do they then all need their own proprietary catalog implementation?
Like if you're just using Snowflake for storage.
Yes, storage and compute, but not the catalog.
So we have plenty of customers that, and like I'm on the open source side. I'm like, I don't even know, what we're selling sometimes. But anyway, so I know that there are plenty of customers who are using external Iceberg tables. They're using Snowflake as the query engine on top of those Iceberg tables. And you are completely fine to have an external catalog. Like we have a ton of customers that run Polaris on their own, and we can connect with it and use it to connect to their external Iceberg tables too. So you can still use Iceberg for the storage, or not Iceberg, for Snowflake for storage and have an external catalog. That's completely fine. Yeah, you're not locked into it all. But I don't think it. I'm not completely sure what the pricing is. I can look it up for you, but I don't really know what the sort of trade-offs would be there for you.
Because with Databricks, I had the feeling, right, it's more like Unity catalog, right? If you have their Spark implementation, like this Atom, then you kind of more or less forced to also go on Unity.
Oh.
At least that's...
No,
it's not...
No, we're not doing that. No. No, we can talk more.
Thank you, Danica.
Thank you.